formulas, definitions, because a while ago I'm just having my introduction. Okay, let's go now to the different expression of concentration. So if you have blank sheet of paper, you can write also because I don't have space in my whiteboard. I cannot write everything here, right? It's limited space only. Okay. Now number one. Okay, we have molarity, moles of solute per liters of solution. Okay. Okay, formality and molarity is just the same. It's just happened that formality will not consider the dissociation and ionization thing. Okay, like that. It will never ionize. For example, what are those substances that will not ionize? Okay, so usually non-polar solvents, right? Am I correct? Especially sugars, family of sugars. The polysaccharides family, the monosaccharides family, the glucose, the lactose, fructose. This will never ionize to water. They will just be dissolved when you stir it. Okay, but that is not an electrolyte. So it will not split its charges during the aqueous solution. Okay, in the solution, I mean. So meaning to say, okay, so this is the situation where the formality is just the same as the molarity. Because, if you have the ionization, dissociation, then this formality will never be applied. So that's why this is limited only to substances that will never ionize, dissociates like that. Or basically, not an electrolyte. Okay? Then normality, moles of solute per liters of solution. No, it's not. Normality is equivalent of solute per liters of solution or gram equivalent solute per liters of solution. Okay, and then after that we have the molality, moles of solute per kilogram of solvent. Normally water, but it depends also on the situation. Okay, and then we have also percentage by mass of solute over the mass of solution times 100. Normally, we have the basis of calculation of 100 grams, but it depends also on the situation. If the problem gives you really specified mass of the solution, then you will never use the basis of calculation 1 gram of solution. Okay? But without that, then you have the basis of calculation, which is 100 grams, if you have the percentages of the solute and the solvent, something like that. Okay? And then we have next is volume percent or percentage by volume. Okay, again, volume of solute over volume of solution. Again, basis of calculation is 100 ml. You get the point? Right, it's gonna be 1 liter. Okay? It depends on the situation as long as it will match your units, but it's expressed in kilogram solute per kilogram of solvent. So grams per kilogram, something like that. Solute is, no, that's moles of solute per kilogram of solvent. It's gonna be mole per kilogram. Okay? Like that is molality. Moles of solute per kilogram. Okay, the percentage of volume is very easy, right? Volume of solute over volume of solution. Okay? Ganun siya. And now, parts per million na ta, guys. Mga siya importante parts per million. Calculation siya sa mga gas device testing. So you would wonder, well, what's this all about? That's also the unit of concentrations. Okay, so it's gonna be parts per million. We need to say grams of solute divided by gram of solution times 10 to the 6. What is 10 to the 6? Remember the prefixes also I teach you a while ago. That is mega. Okay, mega, giga, tera, peta, exa. Okay, meaning to say 10 to the 6 is mega, 10 to the 9 is giga, 10 to the 12 is tera, 10 to the 15 is peta, 10 to the 18 is exa. Okay, and now we go to the negative. 10 to the negative 6 is micro, 10 to the negative 9 is nano, 10 to the negative 12 is pico, 10 to the negative 15 is femto, 10 to the negative 18 is atto. I did not mention that 10 to the negative 1 to the 10 to the negative 4, negative 8, right? Negative 6, because it's very easy. Okay? So 10 to the negative 1, what's that? DC. 10 to the negative 2, centi. 10 to the negative 3, milli. Micro din ang sunod. Get the point? 10 to the 6 micro. Oh, ganan. Okay? Then nano din siya. Okay? And then the positive, so 10 to the 1 is, of course, DC, 10 to the 70, like that, okay? To the point. And then we have 10 to the 3 is kilo. 10 to the 3 is kilo. To the point, mga palangga. Okay? Mag-start sa kilo, 10 to the 3 kilo. 10 to the 2 is, ano siya, centimeter. Centimeter, mura siya may guys, di ba? Okay? To the point. Okay. Holy sharing. Okay. Centimeter. 100 centimeter is equals to 1 meter. Di ba ganun? Okay. Get the point. So muna siya mga palatas. Ako na yung survey number 1. 70 BC. Ganun. Chuchucho. Okay. You get the point mga palangga. Okay. So if we have the 70, atong hinumduman natin siya sa buhuga 10 to the negative 2. Negative 1 sa taon na 10 to the negative 1 is DC. Okay? 10 to the negative 2 is centi. Right? I'll try to write, guys, because sometimes my memory fails. I forgot that 10 to the 1. And then my memory starts to absorb. Then 10 to the 1, it's gonna be, okay, this is now deca. If I will never write also, I cannot remember. But for the higher exponents, I can remember. But for the lower exponents, I cannot remember, see? I take for granted for the lower exponents. You get the point? Okay, so that's it. So if I will say 10 to the negative 1, they see 10 to the negative 2 centi, so I have 10 to the 1 deca, and 10 to the 2 is hecto, right? Hecto. Okay? And then the deca is meaning 10, because 10 to the 1 is simply equal to 10. That's why we have decagon, a polygon that have 10 sides. Because of the prefix 10 to the 1. That's deca. Okay? Like that. And hecto is 10 to the 2, meaning 100. Meaning to say, okay? Meaning to say there are 100, 100 gram. No, 100 sides. Okay, 10 to the 2 one shot. So 10 to the 2. Ano ba siya? 10 to the 2. Okay, 2 zeros na siya. No? Okay. So, bye-bye. Kinamitaw.